In this short segment, I want to describe how the practice of statistics has seen two revolutions in the course of my career as a statistician. In 1970, when I was a student studying for a degree with the title of Computational and Statistical Science, the statistical components of the degree consisted of different topics with no obvious connections between them. You can see the names of these on the screen. And then 2 years later, the first revolution occurred when this gentleman, the late John Nelder, observed that all of these techniques and more could be subsumed within a single theoretical framework, which he called the generalized linear model, and more importantly, could all be implemented in a single software system, which gave the statisticians much more flexibility to interact with their data and choose different models for different data sets rather than having to use a separate piece of bespoke software for each analysis they wanted to conduct. The second revolution came in 1990, and this had a number of elements to it, which all came together in a very nice synthesis. The first was that instead of simply fitting one model to one data set and another model to another data set, and so on, you could think of integrating information from multiple data sets to give you information about different components of an underlying complex system. And within that underlying system, you could use domain expertise to hypothesize a structure of interconnecting links showing causal dependencies between different components of the model. Now, this really was an enormous generalization and very powerful. And the critical thing about the 1990 paper by these two gentlemen, Alan Gelfand and Alan Smith, both happily still with us, was that they saw how they could combine Monte Carlo sampling, as had been used previously in statistical physics, with Bayes' theorem to produce a predictive inference engine that could accommodate essentially arbitrary complex structures of this kind, which go under the general name of hierarchical statistical models. So now we have, in principle, the ability to fit arbitrarily complex models by synthesizing multiple data sets to give us the information we require on components of those models, but put together in a single whole. Thank you.